Okay, so we're going to look at 8.7, which is covering algebraic expressions, evaluating algebraic expressions, simplifying algebraic expressions. First, I'm going to take you through learn. There's a lot of terms and vocabulary you might not be familiar with, so it's going to be worth pointing that out. On this first page, you can see the objective listed. So you want to discuss the vocabulary. You want to evaluate expressions for given variables. So sometimes they'll give you a variable and then they'll give you a value to plug in. You want to identify like terms, and then you want to simplify them by combining like terms. So these terms, these terminologies that we're going to be using will not go away. It's going to stay in math forever. So if you're going to continue doing math, it's going to be worth committing these to memory. Okay, so this first page, this is probably one of the most important here. They say a single number is a constant. A constant is something that doesn't change. It's consistent. So if I just told you 5, the number 5 is the number 5. It doesn't change. It's just 5. So a constant is any number, just a single number. A variable, okay, or the product. So if I multiply a constant with a variable, if I divide a constant with a variable, or divide a variable with a variable, all of these, that's what this statement right here is saying, are called terms, and they give you some examples. Okay, so it could just be a constant like 16, and then separated with a comma, you have 3/4 times x. So you got a number being multiplied times a variable. That is a term. Okay, and then they have a separate comma. They show you a negative number with a decimal as a term. So you have another one with a decimal number, a variable, and another variable. So it can have more than one variable. So you can be multiplying more than one variable or dividing more than one variable together. But as long as it's all being multiplied and divided, it is one term. Okay, so notice you don't see like addition or subtraction separating any of these terms. So here is a better breakdown, a visual of what a coefficient is. So we call a number a constant, but when that number is attached to a variable, we call it a coefficient. Every time you see a variable, there's a coefficient there, even if you don't. Okay, so I'm going to make a note of that. Here's some examples. So you got 5x cubed. It's showing you that the 5 is the coefficient. It's the number in front. 1/2, a fraction, can be a coefficient. A negative and a decimal could be a coefficient. And just the number 3, okay, is a coefficient. It doesn't have a variable attached to it, but we will call it x to the 0 power. So constants are said to be of 0 degree. So we're going to be talking about what a degree is. So degree is, how do they describe it? The exponent of the variable is called a degree. It's really a little bit more than that. So you see a x squared, that 2 is a degree. But we're going to look a little bit more into that because that's vague. So here's some more examples. If you have x, you need to understand it as 1 times x. There's a 1 in front of it. So some people kind of confuse and say x is 1. We're not saying that x is 1. We're saying that that's how many x's are there. There's 1 x there. So this is 1x. Sometimes you need to understand it like this, but they won't write it like that. This is saying a cubed is equal to 1. Or a cubed is the same thing as 1 times a cubed. That 1 is out front. So what I was saying is if you have a variable, it has a coefficient. If it doesn't have a number there, you need to understand that it's 1 in front. If it was negative, it's a negative 1 in front. We're going to talk a little bit more about degree coming up. But they kind of mention it here. It says 3rd degree because of that 3. This says 2nd degree because of the 2. This is 1st degree because it doesn't have a number, but you do have a variable. And this is a 0 degree. While I'm here, let me go ahead and mention it. If I gave you, and really what you want to do is count the variables. So here's an example. I don't know if you'll see one like this, but it's good, it's noteworthy. If I have 16x squared y, I have 2 different variables listed. You need to add all of them up to determine the degree. So here we have 2 x's and how many y's? 1. So understood 1. So the degree of this term, okay, this degree would be 3, because altogether you have 3 variables total. So it's not just looking at the biggest number. If it was just one variable, yes, look at the biggest one. But if there's more than one variable, then you need to add their subtotal, and then that will be your degree. So it's a little bit more than what they give you, so you need to be mindful of that, okay? Now, when they talk about like terms, good definition here, I like it, how they describe it. So it says similar terms are terms that have constants. So just have a constant. It could have 1, 2, 3, a fraction, whatever. Has a constant, a number in front of it. And then the same variables, very important. So it has a constant and then the same variables raised to the same power if they have any exponents. That's what they mean. So like terms are going to be terms that have constants and the same variables raised to the same power. Okay, so they have to, all of that has to be true to be like terms. If not, they're not like terms. All right, so let me give you a physical example of that. So you just tell me like terms, yes or no. Okay, so let's say if I gave you 3x squared y, and then I'm comparing it to negative 2x y squared. Are these two like terms? Yes or no? What do you think?
No.
Okay, why not? Okay, this one over here has x to the second power, and then over here is to the first power. Not the same power. And then this one is y to the first, this one is y to the second. So they have to be the same exponent and the same variable. So even though they both have x, y, they look close, but that squared has to be on the x over here if I want to do the same, and it has to be 1 over y. Okay, so good. You got an idea. So that's what they mean. They give you some examples. If you have numbers that are like terms, decimals and fractions, any type of number you can combine, no matter what form. They show you numbers with variables. So a lot of times people kind of make the mistake of wanting to add, let's say, a 3a to just 15. Okay, but since that 15, if that 15 didn't have an a, you wouldn't be able to add them. They have to be like terms. Same variable to the same power. And then you have some examples that are not alike. Okay, so that is the highlight of this section. That's pretty much most of everything that you need to know. Here's some examples. We got some more examples, which we're going to do our own here in a minute. This is just going over combining like terms or algebraic expression. So before we were talking about what a term is, now we're showing you what an expression is. So expression, and you kind of go through this definition, it is the combination of terms with addition or subtraction. So x squared is a term, 14 is a term, they are connected with subtraction. So when you start adding addition and subtraction with this combination of variables and constants that have been multiplied to make terms, then you end up with the expression. So the first few we saw did not have addition or subtraction in them. Now we do. We have terms separated with addition and subtraction. So we're going to be using those properties that we talked about to simplify and combine like terms. So to combine like terms, this is what you do. You add or subtract the coefficients, the numbers out front, and you keep the common variables. Okay, so the variables will not be changing, only the coefficients, only the numbers out front. And they're going to show you some examples. Okay, so we're going to skip. You can kind of go through those examples if you want to. This is just more saying if you want to evaluate. I do want to point this out. If you use a calculator to kind of help or go back and check the answer, it is very important that you understand the difference between what we're seeing here. So you see a negative x squared, no parentheses, and then right below it you see negative x in parentheses squared. Okay, what's the difference? It looks like the same thing almost. Okay, so what they want you to see is that if you have the negative by itself, not in parentheses with your term, the calculator, if you plug it in, is going to assume that that negative is separate. So if you type negative 6x squared into a calculator, this is what the calculator does. It says, okay, negative 1 times 6 squared. It just separates it. And then it squares the 6. 6 times 6 is 36. It multiplies by -1, and it gives you an answer of -36. Now, you might be wanting to say -6 squared, okay? If you wanted to understand it as -6 squared, then you need to put the negative in parentheses. That's the only way the technology is going to understand it. So if you put it in parentheses, now it says, okay, -6 is being squared, and then they multiply -6 times -6, and the negative and negative multiply together, make a positive, so you get positive 36. There's a big difference. So you need to understand that whenever you're plugging in and solving expressions, doing it by hand or using technology to help you out. Because this looks the same, but it's going to compute very different whenever you get it. So -36 is not the same as positive 36. I'd rather have 36 in my bank account versus having a negative and being overdrawn and getting fees. Okay, so that's the main difference there. So be careful. And I think that's probably going to be it. I don't remember seeing anything else. So some more examples that you guys can kind of go through is extra if you want. They got videos. We're going to do our own. Okay.